welcome back. Today we're going to be talking about section 2.2 function notation. Last section we talked about relations and functions. Now we're going to be talking about what they look like as an equation. Okay, so now usually when we talk about an equation, okay, we're going to see something as like y equals. All right, now let's say y equals 2x plus 1. Okay, so that's the old way that we're going to be seeing things. Now, really, all we're going to do is change one aspect, and that aspect is going to be that y. So simply, all we're going to do is instead of writing that y, in function notation, we're going to write the same thing, but all we're going to write is f of x. Okay, so now that's read as f of x, meaning the function evaluated at x. It does not mean f times x. So really all we're going to do is rewrite that as y instead of y, and it's just going to be equals 2x plus 1. Okay, so it's the same thing. All we're doing is changing one aspect. Okay, cool. Now everything's going to work the same as y equals. Okay, the domain is going to be all of our x values still. Now my range is usually all my y values, but when we're talking about function notation, we're talking about all of f of x values. So it's the same thing as saying our y values. Now next section we're going to go ahead and graph, but if we're looking at a graph, we're going to go ahead and graph data. Okay, our inputs are still the same, our x values. Now our outputs are a little bit different. They're going to be listed as f of x values. So if we have a chart or a table, I'm going to have my input as x and my output as f of x. And it's going to look the same way. So when I input it 1, I output it 2. When I input it 3, I output it 4. Something of that nature. Okay, cool. Now, when we go ahead and visually see a function, okay, so if I have f of x equals 4x minus 2, really, like I said, all that's saying is y equals 4x minus 2. So I want to go through these examples and see which one is equivalent. So I want to see which one is the same. So when I go through, y equals 4x minus 2, which is that one. Okay, so that's my equivalent equation. All you're doing is switching out f of x for y. Okay, now, when we go ahead and evaluate, okay, when I go ahead and evaluate, all you're doing is plugging values in. Okay, now this says solve for f of x or g of x. So now the f is just the name of the function. So I could have f of x here, and the notation is going to be a f of, whatever I evaluate it as. In this case, for example, 2, let's change that f to a g. Now nothing changed. All I'm saying is that that function is called g. Okay, so I would say g of x. Okay, so let's go back to example 1. This says solve for f of x and g of x. Okay, so I want to solve. So now it says solve for when x is 2. All that's saying is solve my function when x equals 2. Okay, so now what you're going to do with that 2 is you're going to plug it into your equation. Now I see 2 x's here. I see one there, and I see one there. Simply, all you're going to do is take that 2 and plug it into both sides. So I'm going to have f of 2 equals 4, remember what that is, times 2. Okay, now the left side is just the notation f of 2, so you don't have to do anything with it. All you have to do is simplify the right side when I'm solving for f of x or g of x. Okay, so now 4 times 2 is 8. Okay, now my right simplified, all I'm going to do is bring down my notation, which is f of 2, and that's my final answer. So all I'm saying is when f is 2, sorry, when x is 2, my output is 8. That's all you're saying. Okay, now good. My next problem is going to be a money problem, but now I'm dealing with g of x, so my final answer is going to have g of something equals whatever my value is. Okay, cool. Good luck. Alright, so my next example is going to be the same as what we just did. It's just going to be illustrated a little bit differently in the beginning. So now I'm still evaluating and plugging in a value, but in this case I have f of negative 2. Really, This one just said when x is positive 2, so it listed you out what x is. But this doesn't necessarily tell you what x is. But what is x in this case? If I have f of x, this is f of negative 2. So really, x is what? Negative 2. So all you're going to do is take that negative 2 and plug it in for your value of x. So really, you're going to have f of negative 2 equals 8 times negative 2 minus 1. Okay, like I said, for these problems, you're just going to simplify one side. You're not going to touch the notation side, the side with the f. All you're going to do is simplify the right side. So in this case, what does the operation tell me to multiply? 8 times negative 2 is negative 16. Bring down what I didn't use, minus 1. Negative 16 minus 1 is negative 17. Okay, once I simplify that right side, I am going to bring down my notation of f of negative 2. So this is saying when x is negative 2, okay, my output f of x is negative 17. Awesome. Why don't you go ahead and try example 4 for money problem. Good luck. Alright, so for the next couple of examples are a little bit different. Now this is solve for x. Okay, so the last problems were really solved for f of x, now I want to solve for x. Now this is saying f of x is 4. So really this is saying y equals 4. Now when I look back at my equation, this whole side, f of x, is like saying y. So really, if that whole thing is y, and I'm saying y equals 4, all you're going to do is replace this whole value, with that whole notation with the number 4. Okay, now 4 equals what on the right side? 4x. Okay, good. Now that I have my notation out of there, all I'm going to do is isolate my variable of x. In this case, I'm going to divide both sides by 4. Divide both sides by 4, and I'm left with x is equal to 1. Okay, awesome. Now, this is saying f of x equals 4, right? That's what the notation is saying. F of x equals 4. Now, what did I find out my value of x is? 1. So to complete this notation, all I'm going to do is drop that 1 into my notation as f of 1 equals 4. Okay, awesome. Now I'm going to have you try example 2 in this case for money problem. Remember, you're going to take that whole value of f of x and plug it in for f of x there. Awesome. Okay, same thing here. It's just we're going to have this rewritten a different way. So this is still saying find x when f of x equals 15. So if f of x equals 15, I'm saying that whole side equals 15. So to rewrite that, you're saying 15 equals 8x minus 1. Okay. Now for when I'm giving you f of x, you're always going to end up solving the equation. Okay, so that's when you're going to have to move things to both sides. Okay, in this case, I need to add 1 to both sides. I'm left with 16 equals 8x. Last step, divide both sides by 8, divide both sides by 8. 16 divided by 8 is 2. I'm left with x is equal to 2. Okay, and that's going to be my answer. Now, if I ask you to write this in function notation, I gave you the notation already. Okay, but now what's x? X is 2. So you're going to rewrite that with a 2. So this would be f of 2 equals 15. Cool. That's going to be my answer. Go ahead and box that off. I'm giving you a lot of money problems today. Number 4 is going to be a money problem. Good luck. Alright, lastly, now if I give you the notation, it's going to be very simple to kind of pull out the ordered pairs and like what I would plot on a coordinate plane. So this is graphing using function notation. We're not going to graph until next chapter, but I want you to understand how to pull those points from function notation. So now this says f of 5 equals 7. So that's saying x equals 5, right? Because that's my x in there. And my y is like what this whole side is equal to. So that's 7. So if I want you to write an ordered pair, all I'm going to do is write x comma y, which is 5 comma 7. Okay? Really, simply all I'm going to do is drop that in my first coordinate, drop that in my second coordinate, call it a day. Okay, so in this case my function is g, so g of 3 equals 4. The ordered pair I would plot on the coordinate plane would be 3 comma 4. Okay, these aren't going to be money problems, but I want you to go ahead and try those. Okay, now finally, for your last type of examples, seeing function notation. If I give you a table, now a table you would go ahead and plot these points, right? And now I have x comma f of x, so that's just saying like y. It's the same thing as saying y. Okay? So when I want to go ahead and plot, really what am I going to plot? I'm going to plot negative 1 comma 3. I'm going to plot negative 4 comma 0. I'm going to plot positive 8, 1. I'm going to plot 4, 7. So that's if I wanted the ordered pairs, right? That's if I want to graph. What if I wanted to write these in function notation? Okay, so if I want to write in function notation, all you're going to do is have my notation as f of x, and you're going to write it as, all you're going to do is plug that value in for x. So in this case, it's going to be f of 4 equals, what is f of x equal? 2. In this case, it's going to be f of 2 equals what? 9. Alright, I want you to try the next two. No money problems for this one. I just want you to practice, then you're going to move on to your multiple point check. Alright, good luck, and I'll talk to you next time.